Okay, did you find the error? I hope you did. It took me a while. But I did it on purpose. So, let's see. Where was the error? Where was the first error? Everything was going well. Until we got here. Yeah. So let's see, this was my first row operation. That went pretty well. My second row operation, everything was going great until I forgot that when I add 1 plus 0, I get a 1 here. Such a big mistake. Yeah, it throws everything off, as you saw. So then this third row operation I should have had, which was multiplying the third row by a -1. I should have had a -1 there, right? And then my fourth row operation, which was taking a -1 times row 3 and adding it to row 1, that should have given me a 1 here. So in this last matrix, I should have had, the B should have had a 1 up here and a -1 here. All right, so correcting for that up here in my test, this is why we test, if we do things by hand, replacing that with a 1 and with a -1, now it works, okay? Mind you, that's just testing in the one direction. If I didn't have the ability to just multiply these two matrices using the graphing calculator, I would also check that this is the same thing if I get BA. So question, is that true? Well, I did check using the graphing calculator and I just said, here's the matrix A. What's A inverse? Using the inverse button. Right? Let's see if I can show this to you. Trying to work out how I can show you stuff on the calculator. I don't think this is going to happen, but I'm going to try. Can you read that without glare? See, I get hold of A, and then I just use, you pull up A, and then you just use that button right there to get its inverse. And there it is, to check your work. Right, okay. So we learn from that. Now, the whole reason I'm emphasizing showing you the row operations here is so that you can move on to the next skill you need, which is to come up with something called the associated elementary matrices. Okay, so reviewing what we did over here. That process over here was schematically what we're doing over here. We had a matrix A, we put it in with the identity, we did row operations on it, and we got down to something that looked like excuse me. In the end, we stopped when we got an identity matrix here, right? We stopped when we got an identity matrix here. This thing, which we were calling B here, turned out to be A inverse, okay? All right, so that process, why have I been making you rewrite one row operation per augmented matrix? Because of this. Every time you do a row operation, there's an associated, so every time you do an elementary row operation, elementary row operations call that because they preserve solution sets, right, of systems. Every time you do one of those, there is an associated elementary matrix, which you find by just performing that same operation on the identity matrix. So for example here, the first row operation was get a new row 3 using an old row 3 added to -1 times row 1. What does that look like? So if I have an identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, and I multiply its third row by a -1, so I get a 0, 0, -1, so there's my -1 times row 1. Now you can see why I write out the directions each time. So -1 times row 1 on an elementary matrix is going to look like -1, 0, 0, I add that to row 3, what does that give me? If I add that to row 3, I get a negative 1 there. So now this is E1. And you notice that E1, the first elementary row matrix, is always the second half of this augmented matrix. But that's the last time, okay? You should observe, oh yeah, that's the same as that. So that's what's going to go into E1. 1, 0, 0, 0, 1, 0, negative 1, 0, 1. The second row operation was to take an identity matrix. We start over with an identity matrix. And perform this row operation on it. Negative 1 times row 2. I would put a negative 1 there. Add it to row 3. Well, that's going to look like this, right? If you multiply that one by a negative 1 and add it to this one, you're going to get that. So that's E2. 1, 0, 0, 0, 1, 0, 0, minus 1, 1. The third elementary row operation. I'm going to perform it on the identity matrix. So here's a copy of the identity matrix. What is this one? This is just multiplying a row by a negative 1. So if I perform that operation on the identity matrix, I get this, right? Third row multiplied by negative 1 there. So that gives me 1, 0, 0, 0, 1, 0, 0, 0, minus 1 there for E3. Okay. Can you stop the video and do E4? You should. Okay, so let's say you're coming back for your E4, checking on that. Again, you start with an identity matrix and you simply perform that one operation on it. What does it look like? Negative 1 times row 3, so that would put a negative on this row 3, added to row 1. Well, that's going to put negative 1 right up there. So E4 looks like 1, 0, minus 1, 0, 1, 0, 0, 0, 1. Okay. That's a good low-level quiz, early test problem. We're going to come up with the elementary matrices that are associated with reducing this augmented system to one that looks like this, right? So now, we're not just doing this in the void. It turns out, if you think about it, every one of these row operations that we're doing here, we could reverse it. Each of these is, we could say, invertible. It has an opposite operation. Like, what would be the opposite of creating a new row 3 by taking the old row 3 and adding a negative 1 times row 1 to it? What would turn this back into an identity matrix? Well, a new row 3, getting rid of that negative 1, equaling to that old row 3 plus 1 times row 1. That's reversible, right? So this elementary matrix here has an inverse, something that undoes it, or an elementary matrix that undoes that row operation. Same thing true of this row operation, multiplying by a negative 1. We can reverse that, right? That took an identity matrix and multiplied that third row by a negative 1. How can we reverse it? Well, for that one, to undo getting a negative 1 there, we would multiply by a negative 1 again on that third row, right? So that type of row operation is also reversible, invertible. What's that other type of row operation? Switching rows, right? How would you undo that rows 2 and 10 were switched? switch them again, right? So every one of these elementary row operations is reversible. And what we're going to find, therefore, is that every one of these elementary matrices here are themselves invertible. That's going to be key. So elementary matrices are invertible. This is going to be a key fact we're going to use in the next video.